Oh, I'm glad you're here because we are about to learn how to analyze discrete numerical data. You remember, discrete numerical data is normally the result of counting. For example, Mr. Aneri, that's me, is exhausted with people coming to class without pens and pencils. True story. He decides to survey his class to find out how many pens each student owned, and their answers are shown on the right. So for example, you can see the first person I asked said, I have 1 pen. This person has 6 pens. This person has no pens or pencils at all. I guess no pens at all. It does say I asked how many pens. You might want to think, well, how many people did I ask? I asked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people. Students, probably. Okay, so there are lots of ways that we can analyze and visualize and explore this data. First, let's create a tally and a frequency table down here. Frequency means how many people gave each answer. So I'll put the number of pens, so the different answers people could give. The smallest answer was 0, and the largest answer was 6. So I'll go from 0 all the way up to 6. Do you notice that even though no one said 5 pens, I'll still put that here. And I'll still put it in my graph too. I don't just want to ignore it just because no one gave that answer. Okay, and now let's do a tally. A tally will seem a little bit silly here because there are only 12 answers, but if you had 100 answers that you were going through, or you were collecting them, I don't know, at the front of the school or the front of a classroom as people went in, then a tally can be a really fast way to really quickly record it. The way we do it is the first person said they have 1 pen, so we can put a tick or a line on the 1. The next person said they have 6 pens, so we'll put a line on the 6 pen tally. Next person says 1 pen, so I'll put another line there. Next person says 3 pens, so I'll put a line here. Next person said 4 pens, so I'll put a line here. Next person said 2 pens, 1 pen, 2 pens, 0 pens, 1 pen. The next person also said 1 pen. So now that I've got to 4, to show 5, I do the next line as a diagonal line like this, and that shows that it's a nice group of 5. 5 people so far have said they have 1 pen. And the last one here is an extra person with 1 pen, so I'll put that here. So for a tally, for each group of 5, the 5th line, instead of putting it at the end, use it to cross off the group. Okay, good, so we've got our tally. Now let's do the frequency. Frequency just means how many. It's the count. So how many people had 0 pens? Just 1. How many people had 1 pen? 5 plus 1 is 6. How many people had 2 pens? Coincidentally, 2 people had 2 pens. There's one person with 2 pens and another person with 2 pens. How many people had 3 pens? Just the 1. How many had 4? Just the 1. How many people had 5 pens? 0 people. There are no people that had exactly 5 pens. How many people had 6 pens? Just 1. Good. So now we can draw a column graph. A column graph is really good for discrete data, and it has gaps between the columns. We'll see later that a histogram, which is a bit different for continuous numerical data, does not have gaps. But a column graph, discrete numerical data, we put gaps between the columns. There are lots of things we need to remember for a graph. For example, we need a title for the x-axis. Let's call this the number of pens, being from 0, 1, 2, 3, 4, 5, and 6. Notice that even though no people had 5 pens, I'm still going to put a 5 there, just because then these go up, one at a time. They go up in equal intervals, equal increments, I suppose. This axis here, the vertical axis, I'm going to plot the frequency. So how many times did this happen? I can put little tick mark, put an axis scale here, going from 0, 1, 2, 3, 4, 5, 6, 7, 8. You might notice this little detail. For a column graph, the number is in the middle of the column. So I'm going to have a column here, and the number is in the middle of this column. Whereas on the vertical axis here, the 0 doesn't align with the middle of this grid, does it? It aligns on the line, on the grid intersection here. Notice the 1 is on the line and the 2 is on the line. Whereas here, it's between the lines. So then the 0 will end up in the middle of my column. Cool. So I've got that. I can now start graphing it. How many people had 0 pens? Just 1. So I can get my ruler, grab your ruler, get your ruler, use your ruler for this. And 0, okay, so 1 person had 0 pens. How many people had 1 pen? Well, the frequency, the count, how many people was 6 people. So I can go up there to 6. You don't really have to fill it in if you don't have time, that's fine. How many people had 2 pens? Coincidentally, 2 people had 2 pens. How many people had 3 pens? Just 1. How many people had 4 pens? Just 1. No one had 5 pens, so I don't need to put anything there. And how many people had 6 pens? Just 1. Cool. And now I have a beautiful graph. It has axis title on the horizontal and vertical axis. Good. It's got an axis scale on the horizontal and vertical axis. Great. My numbers, they're equally spaced. You know, there's 1 space between each column. Good, so equally spaced. They go up in equal increments. These go up in 1s. 1, 2, 3, 4, 5, 6. And I've chosen to go up in 1s here as well. 1, 2, 3, 4, 5, 6, 7, 8. I am missing one thing though. Up here, the title. How many pens does each student own? Is a sensible title for that. You know, you could also call it pens for each student, or, I don't know, causes of Mr. Airy's frustration. That's just a joke. Yeah, good. I have a question though. Do you notice on the side here that I went up in 1s? 1, 2, 3, 4, 5, 6, 7, 8. What if I needed to go all the way up to 30? If I went up in 1s, 1, 2, 3, 4, and so on, would I have enough room to get to 30? Probably not. I'd go to 8, 9, 10. Oh, and now I've run out of room. If I needed to go up to 30 instead of just, really I need to go up to 6 here, then instead of going up in 1s, I could go up, for example, in 5s and do 5, 10, 15, 20, 25, 30, and then it would fit. So if going up in 1s doesn't fit, you can try going up in 5s or 2s or 10s. Nice round numbers like that are really good. Why do you think here I didn't go up in 5s? I certainly could have gone up in 5s. 5, 10. I don't have any numbers bigger than 10, so I would have been able to fit the whole graph in here. But then it would have been very small, wouldn't it? So that's why I went up in 1s. 1s was enough to use most of the space, but still fit all of these numbers. Now, let's look at a few more questions that are interesting to analyse about discrete numerical data. First of all, this one is probably one of the most important. Maybe it should have been the first, which is how many students were surveyed. There are a few ways to do this. One way is if you have a frequency table to add a total row. And the total row, you'll just add up the number of frequencies. You'll find the sum of these things. 1 plus 6 plus 2 plus 1 plus 1 plus 1 is 12. Because the frequency is how many people gave each answer. 6 people said 1, 2 people said 2, and so on. So if you add up all these things, that's the total number of people that answered. I guess another way is we have the raw data here, the original data, so we can just count the number of people that answered. So there were 12 students that were surveyed. What percentage of students owned less than 3 pens? That should really be fewer than 3 pens. Whoopsie, because we're counting them. To find one quantity as a percentage of the other, blah, blah, blah. Well, first of all, we need to figure out how many students owned fewer than 3 pens. This one student owned 0 pens. They match that description, so that's good. So that one we will count, yes. I'll just put a little dash here so I can remember that we're counting this one. 6 people owned 1 pen. Yeah, they own fewer than 3 pens. 2 people own 2 pens. That's fewer than 3 pens. This one person owns exactly 3 pens. Do they have fewer than 3 pens? No! They have exactly 3 pens. So it is these 3 numbers here. All of these students, 1 student plus 6 students, plus another 2 students. These students own fewer than 3 pens. How many are there? There are 9. 1 plus 6 is 7, plus 2 is 9 students own fewer than 3 pens. Now we need this as a percentage of students. So first, let's write it as a fraction out of the total. To write it as a fraction, it's 9 students out of, how many students were there in total? 11 students. So 9 out of 11, now we've written it as a fraction. And then we can multiply it by 100%. Really, we're multiplying it by 100 and then adding a percentage sign at the end. So on your calculator, my advice for you, never press the percentage button on your calculator. It will only confuse you and give you a result that confuses you. Just do 9 over 12 times 100. You can also do it by hand because, for example, we could simplify 9 over 12. There is a number that goes into 9 over 12, that goes into 9 and goes into 12, which is 3. So we can divide 9 divided by 3 is 3, 12 divided by 3 is 4, put the times 100%, 3/4 times 100 is 75%. But alternatively, just chucking this thing here without the percent sign in your calculator will give you the same answer. So most students own less than 3 pens. That seems sensible to me. Finally, we're asked to describe the distribution of the data. You can see our graph that I've copied from before is down here, and it sort of looks like... So most of the results are down here, and I would say the average is probably here as well, but there are some at the positive end, some larger numbers. If we go back to our little reference, thank you, Hazy Mathematics, for this little reference. It's not quite symmetric. The positive end is really stretched out. The larger numbers are really stretched out. So this is positively skewed. The data is positively skewed, or it is a positively skewed distribution. Yay! Cool. I hope this has been helpful for you, and I will see you for the next video.